so we can get going. Okay, hello everyone and welcome to Handmade Hero, the show where we code a complete game from scratch. No engine, no libraries, just our own like sagacious little fingers typing away. Basically we're doing this so that we can see the complete set of code and know everything about the complete set of code necessary to run a game on a modern computer. And right now we're at the point where we have decided to start looking at, we're in the middle of doing engine architecture work. And we've decided to start looking at how we want to handle the concept that when two things collide, meaning, say, for example, a sword that has been thrown touches an enemy, we want to start responding to these sorts of things. We want to start creating sort of that part of the program, which is where gameplay really starts to take shape, actually, which is interactions between things, right? Most gameplay is sort of developed as the interaction between things. When this touches this, this happens, right? Or when you walk over this kind of thing, this happens. And so now is a good time, I think, for us to start looking at that, and that is what's on the agenda for today. I also have a little sticky note here because someone on the forums pointed out that we had a cut and paste bug. A lot of times when I'm reorganizing code on the stream and I'm trying to talk it through, it's a little bit difficult for me. So sometimes things sneak by, and I kind of rely on people who are watching to catch the cut and paste errors that I would normally be catching, or at least trying to catch if I were working normally. And so somebody, I greatly appreciate this on the forum, someone caught one for us, and I wanted to go take care of that as well. But before we do that, let me just remind everyone that if you did pre-order the game on handmadehero.org, you should have gotten an email that gives you a link where you can download the source code. And if you would like to follow along with what we're doing today, today is day 68, so unzip day 67 source code into a directory. That was yesterday's source code, and that's where we're at today. And so if you want to follow along with us, that's how you follow along. You'll be exactly at the same place I am right now. All right. So first, let's take care of this note, this typo note, so that we make sure that it doesn't stay in there and cause us problems later on. What they said was that when we were rearranging some things in in the move entity call, which is in our sim region code, in the move entity call, we did a cut and paste where we were supposed to be using test entity. You can see it here, right? We were supposed to be testing test entity's non-spatial flag. We were supposed to be doing this test right here on the same entity, and we basically had a typo there. Now, one thing that's interesting about that too is we haven't quite worked out exactly how these guys are going to work with the collides versus non-spatial, that sort of thing. We have a number of different types of flag tests that we're probably going to do. It's worth noting that at some point we may, to avoid cut and paste errors like this, but also to sort of loft these tests out into some kind of more composite, pragmatic call that's like a more obvious predicate. What we might want to do is start making compound tests. So we can say, if this is the type of entity that should have blah done to it, then do the thing. And that would roll up these kinds of tests in a way that might make them easier. Now, we don't actually know if that's true yet because we haven't quite worked this out yet. So the fact that I'm testing the same sort of thing here and here isn't necessarily a good indication that we should do that just yet, but it's just something to be aware of as you're going through. You want to notice these sorts of things, go, oh, okay, I sort of seem like I'm doing that. Maybe that's something that we could take a look at in the future and simplify the code a little bit, reduce the possibility of errors, make it easier to read, and so on. But that was the typo that they'd called to our attention, so I'm glad we got that in there. That that'll prevent it from having a little lurking problem for us. Okay, so if I remember correctly, we I believe put a put a to-do in here somewhere. That was for tomorrow. Yeah. So the thing that we were going to start out with was our movement routine as it is has a bit of a limitation to it that we wanted to address, which is that right now when things move, there is no notion of how far they are allowed to move. So basically, the equations of motion, we compute them for anything. It basically tells us, given an acceleration and a velocity, how far this thing should have gone. We move them there, and we do collision detection along the way to see if there's anything that they would have run into. That's all well and good, but, excuse me, I'm not very sick now. I'm sort of recovering, but so yeah, I'm a little off from having been sick for the past couple days. It happens. Anyway, so the thing that we don't have, though, is the concept that things only exist for a certain amount of distance. So that's the kind of thing that doesn't really happen in the real world, obviously. Like, there really isn't such a thing as stuff that exists over a distance in the objects that we see around us. That's not a concept, but in a game, that is a very real concept. Obviously, anyone who has played any kind of a game where, you know, the hero throws a sword or shoots a gun thing or does whatever, and there's a limited range of travel on it, and when it gets to the end of that range, it is destroyed, you know, it disappears or whatever it does. So obviously there's this kind of concept in games which doesn't really super exist in the real world maybe, but it's this concept that things only have this limited range, and it's not as simple as in the real world things like falling to the ground or gravity or that sort of stuff. It's not just that it lands and stays where you threw it, it literally like goes away or something, right? And so what we want to do is, even for things, look, we don't want to say that things have to touch the ground. Maybe we want them to just travel in a straight path, no gravity, no nothing, right? They're magical or something. We want them to be able to go, and then when they've used up as much distance as we said they have, we want them to go away. Now, what we were doing before, which is kind of a little bit of a hack, was we were just saying, okay, every frame we'll let the move entity call take care of wherever the guy's going to go. We'll look at where like the sword was, and we'll look at where it is now, and we'll take that distance and we'll subtract it from however much we said you were allowed to go. However far this sword thing is allowed to go, we'll subtract it, and when that gets to 0, we will know that it's gone as far as it can, and we'll get rid of it, right? That's what we'll do. That's all fine, but there's kind of a hidden inaccuracy in that, right? And that is that if the sword in that time step doesn't exactly travel the distance that would bring it to 0, if it travels more than that distance, then technically the sword has gotten this little extra, this little bit of extra motion, right? That it wasn't technically supposed to have. It was supposed to only go part of the distance that it was allowed to travel in that time step, not the whole distance. And so what we'd like to do is tighten up that accuracy. That's the kind of thing that I guess is kind of good for speed runners to exploit if they know that they fire it at just the right time or something, it travels this extra amount. I mean, I don't know. It's the kind of thing that happens in games all the time. Obviously, tons of games have shipped with exactly that kind of an algorithm running them, but we can do better, so we should do better. So what I'd rather do is have the movement routines themselves understand that there's a concept of a resource, essentially, and that resource is distance. And when it is moving something, it's not that expensive for us to go into those movement routines and say, okay, look, make sure that you look at what your resource budget is, and when you're moving someone, don't move them too far. If the resource budget would run out during that movement, you stop them there, right? And that'll make it so that no matter what the update situation is, or no matter what the frame rate, no matter what whatever, it'll still do a good job of obeying those limits, which is what I would prefer to have happen, rather than sort of the sort of hand-wavy solution of the other way. So what I'd like to do is go ahead and introduce that concept. So inside our move entity call, right, we already are kind of set up in a good way to have this work. And the reason that I say that is because you'll notice that we already have, what we do at the outset is we take the equations of motion, the physical equations of motion that govern how real things move in the real world. We compute where the player, we still call it player because we originally wrote it for the player, but really it's any entity now. Where the entity should be, right? And then we go ahead and we enter this iteration where we're going to go through and we're going to see if we can move them there, and we test against things that they're going to collide with, right? That was how this loop worked. And if they don't collide with anything, then we put them there. If they do collide with something, we stop them there, and we sort of remove that, whatever the sort of angle was that the thing was that they hit, we allow them to keep traveling along that, but we get rid of their ability to move in that other direction. Now, because we did that, that means we've already introduced into this routine the ability for the code to handle the concept of not moving the whole way, because that's what collision is. It's the thing that stops you from moving the whole way. So the question is, can we just go ahead and add something else in here that's another reason, another thing essentially that will stop you from moving that whole way, and in this time that thing would be that movement budget, how much you would be allowed to move, right? And so what I want to do is take this t-min, right? That t-min is the t along the motion vector. What I want to do is take that and say, okay, we've got this t-min. The t-min thing is how far that it will actually be allowed to move. And we're going to go ahead and make that t-min be set to something that might be less than 1 if it doesn't have enough budget to actually get to where it should go. That would automatically handle this for us at some level, right? And the hit entity part will still control whether collision happens, but regardless, because it only does tmin times player delta when it does that movement, that's a pretty trivial way for us to go ahead and make sure that you're not allowed to just keep using it, right? So anyway, so this starts to inform one aspect of this that we had dithered about when we originally wrote this code, and it actually suggests that maybe we want to write it in sort of the other way that what we did, right? If you remember, when we were originally writing this code, I said I'm not sure whether I want t to be talking about the motion along a vector where 1.0 means moving all the way to the end of the vector and 0 means the start, or whether I want the vector to just be a unit vector, have unit length, and have the t go from 0 to the total amount of meters covered, so that t is actually a distance value. Because we could write it either way, and really all that determines which way we did it is whether the player delta vector gets normalized first or not. And I'll go to the whiteboard just to kind of give you a little bit of a refresher on that for people who might be a little hazy about that aspect of the code originally. So let's go ahead and start a new place here for our day 68. So here's day 68. So there's two ways that we could write the collision routine, and I talked about them at that time. One way is that the motion vector, right, here's the beginning p, and here's the new p, right? Here's where we go. I think we also typically were calling these p and p prime, for example. So here's where I am, here's where I'm going, and this director here, this vector here was called player delta in our code, right? That's what we were calling this vector right here, right? This guy. That's the player delta, right? And that player delta has a real length. And so what we were doing is we were saying t equals 0 meant you were here, and t equals 1 meant you were here. So basically t times the player delta just tells you how far along this you were. But the other way that we could have done it, right, is we could have gone and said, all right, instead of that vector that goes the whole way, we're going to normalize this vector. Now we don't know what, we don't know what the time step is, so actually that may have made it longer. We don't know, right? Probably it would make it longer given our timescales here. But point being, we produce a vector that's simply a unit vector, right? It has length 1 that goes in the direction of travel. So it's pointing towards this p prime, right? And then t equals 0 still starts us at the starting point. But now we have t equals essentially the length of player delta, right? Whatever this vector's length was originally, that is now what t goes to. And we now have sort of this like normal, this player delta normal, if you will. Player delta normal, right? Here, it's unit length, it has length 1. And we're moving along that. And the attractive part of that obviously would be like, okay, now t really is a distance, so we can just set the t equal to the movement budget at the beginning, and that would make it so that we could never get past there as we go. So it's something to keep in mind that we made a decision between those two, and we ended up going with this one, but maybe that was the wrong idea. I don't know. So what we're going to see now is let's try to go ahead and put in the movement budget concept to this function using the way that we originally structured it. And then we'll see if it becomes too onerous, and we'll make a judgment call about whether it would be better to write it the other way. So hopefully that makes some sense. Okay, so here we go. We come in here, and what we want to do at the outset is we want to make sure that our first tmin, obviously whatever we're initially setting our movement to, that our initial tmin would not go further than our maximum allowed distance, right? And so what we can do is we can imagine passing it in here, I suppose, where basically say maximum distance, or we could say distance limit, maybe, might be one way to say it. So the distance limit comes in here, and what we want to do is we want to make sure that over the course of our iterations, we don't ever use any more than that. So what we could say is like, okay, distance left equals distance limit, right, like so. And then each time through this iteration, we'll remove some from that distance left, okay? I guess I could call it distance remaining to make it so that we're not confused about left and right, you know, that sort of thing. Distance remaining sounds a little bit better. So that's our distance limit. Now, what I could do here is I could basically say, Yeah, I think what I want to do is I want to set this team in to be only allowing you to move that far. And the reason that I'd like to do that rather than dealing with it after the fact is because I don't want to process any entity collisions that would have happened after the movement budget, right? Because if you imagine the case of the sword, if the sword was going to move from one place to another during one frame, and the movement budget wouldn't have allowed it to get to that final place, but getting to that final place would cause it to collide with some entity and cause an event to occur, I want to make sure that event doesn't happen, right? I don't want that event to trigger, because technically the sword should not have been able to reach it, right? So that's the reason I want to set the team in, because the team in will cap how far the collision detector will even check, because our collision detector only considers it a hit if the collision happens before the team in. That was sort of how we were sorting our collisions in the first place, to make sure that the first one happened first, right? Whichever had the minimum team in. That's why it's called team in. It's the minimum T. All right, so we've got our player delta, and if I wanted to compute how long that was going to be, right, what I'd have is my player delta length. At this point, we have a function for computing the length of a vector. We can pass it in here, right? So if I go in here and I take my handmade math.h, right? I take a look at my length. You can see that I've got it. Now it forces some stuff. It's got a fair bit of math. It's 2 multiplied. It's an add, and then it's a square root, right? Now in the old days, a square root would have been an absolute nightmare. Square roots used to be really, 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 really expensive. And you almost never, ever, ever wanted to call square root if you could avoid it. In fact, we used to write functions that would approximate the square root so that we didn't have to call the actual square root. That's how bad it was. But nowadays, processors are actually pretty handy about this, and you can actually get square roots in not that much time. So it's entirely possible that this is just fine, right? And so we'll start with that, and when we actually go to start optimizing our collision detector, we'll see. But chances are, even though that's the sort of thing that would have sent out some alarm bells in my head a long time ago, nowadays it's like, yep, square roots, Intel fixed it for you, right? Anyway, they're still a little more expensive potentially, because I don't know if you have to do refinement steps on them. I don't know how much accuracy you get on some of the newer processors versus the old ones and all that sort of thing. But point being, no matter what the circumstance is, no matter how accurate you need the results, it's still way faster than it used to be, because it used to be pretty expensive. Anyway, so we go ahead and get that length. This is how far now the player delta thing is. So what I would like to do is say, all right, I want to go ahead and make sure that I cap that to make sure that it's no longer than distance remaining. So basically, what I'd like to do is say, what is the ratio? In fact, I guess might be what I'd say. What is the ratio, or how much of this player delta length can we afford to use, right? And so if I take the distance remaining, what I'm going to do is I'm take the distance remaining, I'm going to divide it by that player delta length, right? And what I can do here, I can also go ahead and make sure that that player delta length actually has some amount to it, so that we would avoid a divide by 0, obviously, right? Well, you know, do I even need to do the divide? I'm trying to think here if I need to do the divide. I guess what I could say first is, let's do the simple check. If distance remaining, right, or if player delta length is greater than distance remaining, then we have to deal with it, right? But if it was not, then we wouldn't. Meaning, if the player delta length isn't more than the amount that we have left, then we don't really have to do anything, right? There's nothing that has to happen. So the only case that we really care about is what do we have to do to team in if the player delta length, the amount that we're going to move, is too long, right? And so I feel like all we really need to do at that point is set the team in, which again is how far along the player delta we're going to go. We just want to set that team in to be whatever the right ratio is between these two things, right? So if we know we have a player delta and we want to move it only as much as distance remaining would be, right? Only as much as it would cover the distance remaining. I should be able to just take the ratio of those two things, I believe, and make that work out. Now let me just double check, and I'll sort of draw that out for you guys, so sort of show you what it is that I'm trying to say here. There we go. So if you imagine, right, I've got this situation, and here's my player delta, right? So this right here is the player delta length. Okay, so I'll just call that D for now. We'll just call that straight up D. And then what I'm also saying is I've got another thing which is like a cap, right? And so this is like the remaining. This is that player delta remaining. So we'll just call that R, okay? And so what I want to do is I want to say, I don't want you to go any further than here along that vector, right? So if I know that t, which moves me along this vector, if I know that this is 1.0 and this is 0, right? Then really all I need to know is what percentage, right? That's a percentage, 0 to 1. What percentage of the way along here could I actually go? What percentage is r, right? So I want to know how much of the way r is in D. If the total area is D, how much of it is taken up by R? And that should give me the T value that I actually, my T min, what I could actually go to if the furthest I could go, right? And so that's the ratio that I'm computing there to use to set that T min. So the only thing that really has to be true here is that player delta length has to be non-zero in order for this to work, right? And so in order for that to be the case, we have to make sure that we're never trying to actually do a move when the distance remaining, when the player delta length is going to be 0. But if the player length was 0, we don't need to move the player, right? Or whatever entity we're using. We don't actually need to move it at all. If the movement's going to be 0, that means it wouldn't go anywhere. So technically what we can do here is actually just make this entire loop have to be greater than 0, right? And we just wouldn't have to actually do anything in the case where it was 0. We just wouldn't even do anything at all because it's not possible for it to have any effect on anything, right? It's immediately done in that case. In fact, what we could do is, well, I guess we can't really put it up there because we haven't computed it yet. But basically, this is almost a loop condition. If the amount that we're going to try to move the player by isn't greater than 0, then we are not going to move him. So just stop. Don't do any more computation. Don't waste any more time thinking about it. It's not worth it, right? So that will totally solve our problem for the first iteration through the loop. The problem is this distance remaining actually now needs to get updated by however far we actually did go, right? So at the end of this, when we're about to move the player, what we need to do here is say, well, that distance remaining is going to go down by some amount, right? Now, it would go down by the player delta length if we actually took the whole step. But since we don't know we might have hit something, the question is how far do we actually go? Well, in this case, T-min is to the rescue again, right? T-min saves the day. T-min tells us how far along we went, which again, if we take that as a percentage and we just want to know how far we traveled, we just go ahead and say, well, whatever the percentage was here, if we just multiply it by the total length of that vector, it'll tell us how far along the vector we went in actual meters, right? So all we have to do is say, okay, multiply that length like so, and off we go, right? Now what we might want to do as well is we might want to make this a more, to avoid any kind of floating point nastiness, we might want to make this also an epsilon, right? We might want to say that in general you're not allowed to move people 0.00001 meters or something like this. I don't know exactly how we want to deal with stuff like that, but it's definitely something that when we go through the collision detector is a geometric computation kind of thing. Oftentimes those involve a lot of floating point nastiness. And since we haven't thought through a lot of these things and we have a bunch of floating pointy things we need to think about, I'm not going to really push on that right now. When we actually go do our final version of the collision detector, we'll try to tighten up all of our floatness and try to get rid of as many epsilons as we can. So for now, I'm just going to say what do we want to do for epsilons here? Think this through for the final collision code, right? And so hopefully that's all we really need to do for that. Now, in order to finish our sword stuff here, right, what we would like to do is we now like to sort of loft up this kind of concept of having a certain amount of movement that you can do. I'm going to go ahead and put that into, basically just put that into my, my entity logic, if that makes sense. Oops, that's not the place I actually wanted. So what we want to do is we want to say that entities can have this kind of cap on them, right? And what that cap's going to be, I don't know if I want it to be a flag or not. I'm not sure exactly how I want to do it. There's a couple things I kind of have in my head that we haven't gotten to yet about how I want to do entity architecture, since we're kind of putting that off. I don't think this really needs to be a flag, so I think I'm going to do something that doesn't use a flag for now, even though it might be a little bit gross, because I think when we come back around to it, and I sort of have, like I said, I have inklings of how I want this stuff structured eventually. When we start talking about that for real, I think this will kind of shake out. But anyway, so we'll have this, like basically a distance limit will just be on there. And so any entity can take advantage of the distance limit. And the way that we'll do that for now is we'll basically say that if the distance limit is just set to 0, or maybe some other value like no distance limit, but I think I'm going to use 0. If it's set to 0, then that means you can move as far as you want. But if it's set to an actual value, then you get capped, and it triggers if you actually get down to 0, right? So the way that we'll do that is inside the sword, right? What we'll do is we'll say, okay, instead of entity, oh, we already have distance remaining, so here we go. What we'll do inside the sword is we'll say, all right, we don't have to deal with this manually anymore, but we do have to deal with whatever that exit condition is. What we want to say is that if the distance limit for the sword becomes equal to 0, then we want to make it non-spatial and take it out of the computation, right? It's gone. So all we need to do now is that distance remaining, when we set it, we need to set it so that it's on the distance limit field, right? And now we just have to actually process that field. So what I'm going to do is I'm going to say, okay, we've got a distance limit. It's going to be equal to the entity's distance limit, and we'll pass that limit along. But in the case where the distance limit actually equals 0, we're just going to assume that that's makes people allowed to move however far they want. It's like essentially saying there's no distance limit. So we'll just basically put on some kind of ridiculous maximum value here, like something that you could never possibly ever do, right? Yeah, no one's ever allowed to move 10,000 meters. That's obviously completely ridiculous, so we don't have to care about that. I'll put a little to do here, say, do we want to formalize this number? But basically just a thing that says essentially no limit, right? So we'll do that, and then we'll go ahead and see. I don't actually know if we actually put code in here to test this. I think we probably did, but we can actually go and see what the deal is. Oh, and we've got one more thing we have to do. I forgot. We have to actually decrement the distance limit. Now, I suppose also I don't really need to handle that outside. Inside move entity, if it's actually going to be something that's on the entity, we could probably just handle it directly in there. So actually, I suppose we can just go ahead and do this. This can actually move outside of that into here, to be honest, right? We can actually just put that in there. So that's probably actually fine for now too. Yeah, that seems better actually now I think about it. All right, so basically what we'll do here is we'll say, okay, we'll grab that distance remaining like so. We'll then go ahead and see what the distance limit actually is on the guy. Oops, there we go. And we'll set it. And then this will kind of get subtracted off. I guess what we can do, yeah, and then at the end what we can do is we can just go ahead and write it back. At the end, we'll basically say if the entity's distance limit was not equal to 0 in the first place, we will just write back whatever the distance remaining actually was. And so now that's their new distance limit. And so that way it'll decrement as we move. Every time the entity moves, it will have its distance limit decremented, right? As long as it wasn't set to 0. If it was set to 0, that's kind of the case that says, all right, just let them move however far they want. Don't deal with it. All right, so let's see how that goes, if that does any better for us. That looks pretty good. No big problems there. And so now we're doing exactly the same thing we were doing before, where you can basically spin off an entity, let it go in some direction, and make sure that as it gets to the end, it's going to end when it's moved a certain amount. So that's good. That basically tidies up that for us nicely, and it makes it so it's handled in a nice, clean way that doesn't vary based on the frame rate, which is kind of nice. I think that's a good way. It's a good thing to shoot for. You don't want to have a lot of your stuff in your game be frame rate dependent. It invites a lot of problems when you're trying to ship on different platforms, and it just means that you have a lot less flexibility. It means you can't toggle between 60 or 30 hertz depending on the platform. You just get all kinds of nastiness, right? So all right, that's about all there was to that, and it looks like based on the clock, 8:35, we've still got a half an hour, so now might be a good time to start talking about that collision detection, which is kind of what brought up this stuff before. We were sort of gonna start take a look at that. So if we take you know, just sort of a cursory check here, we've already done, like I said, we've done some of the work. Sorry, I got an itchy eye here. Yeah. Sometimes you get an itchy eye. Sometimes staring at monitors all day in the heat, in the winter, dry heat, the eyes get a little itchy. It's true. Oh. All right. So what we want to do now is say, okay, we've already got our collision routine set up. You know, we planned for this basically. Like we knew what was coming down. So when we hit something, we know we hit it. We've got to hit entity call, right? I'm sorry, we've got to hit entity variable set. So now we know that the entity that we were on, right? This the entity that we passed in here, this sim entity. We know that that entity and this entity hit each other, right? They've collided. And so what we want to do now is introduce the concept of some collision response. Now, collision response is kind of a nasty problem for a number of reasons. One of which is not one that we're really concerned about right now, and that is what you want to happen physically with things, like when things push each other. Like when this thing hits this thing, it's supposed to push or, you know, do stuff like that. That's obviously a physics problem, something that we probably will want to get to once we actually have some notion of what sorts of things in the game will do that, right? When we get to the parts maybe a little further along where we're going to be pushing things, that's something that we would want to think about and deal with. But there's a separate problem, which is sort of game logic, right? It's like, this has nothing to do with physics, it's just when these two things hit each other, I have some game logic that's supposed to happen. Like, for example, when a sword hits somebody, it's supposed to do some damage or something, right? And so the problem with handling these sorts of things, the reason that they become complicated for people when they work on them is because it's a problem called double dispatch, right? This is what it's called typically in programming terms. It's a double dispatch problem because essentially what you have is an operation that depends on two independent parameters, right? You can almost think of it as a matrix like setup, right? If you've ever used Microsoft Excel, you kind of know what I'm talking about here, where you have almost like a spreadsheet, right? Where you have every type of object coming down this way, and you also have every type of object going this way, right? So I don't know what they are. They're like hero, monster, sword, wall, almond milk, right? Hero, monster, sword, wall, almond milk, blah, 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 right? And what you want to do is you want to say, okay, when two things hit each other, I want to write my game logic that's like, what happens, you know, when a sword hits another sword? Like two swords collide. Well, that's this logic, right? And what happens when a sword hits a monstar, right? Well, this logic happens. Okay, well, does the same thing happen when a monstar hits a sword, right? Which would be here. Presumably they're symmetric. I don't know, they wouldn't have to be. You could sort of make system rules where it's like there's a precedence to who got evaluated, I don't know. But basically what you can imagine is most of the time they're going to be symmetric, meaning you don't really have all of these. You only have like an upper diagonal or a lower diagonal system in math terms, right? Meaning that basically all of the things that happen if you took this stair step of the diagonal, right? All of the things that happen in these cells are actually the same as what would happen reflected along this diagonal, right? So when a hero and a monstar collide, we probably wouldn't do something different than when a monstar and a hero collide. Meaning, in this routine, we probably don't care which one was passed in and which one was hit, right? Like who was doing the movement, we probably don't super care most of the time. Now, that may not necessarily be true, but it's probably true. Because even in circumstances where you do sort of care about who was initiating the collision, meaning, just to give a more concrete example, suppose we have something where there's like a block that's going around on a path, right? So we've got this sort of block and it's moving, and you know, over time it just kind of moves around. And we've got the hero, and the hero is here, and you know, he can run into the block. And maybe we want some logic that says something like, okay, we want the hero to have to actually run into the block. If the hero was just standing here and the block collided with him, it would just push him. But it's only if he pushes into the block that something happens, like the block lights up or triggers something, right? So even in those circumstances, we probably wouldn't implement it by making this matrix asymmetric, right? We probably wouldn't do that, or asymmetrical, I should say. Symmetrical, asymmetrical. So asymmetric, so interestingly enough, symmetric was not ever a word. It was symmetrical that was the word. And symmetric is some kind of newfangled word that people introduced recently. So I'll try to use the old school. Let's learn the old school math word and say symmetrical. Of course, asymmetrical didn't exist for a long time too. That's asymmetric and asymmetrical are actually pretty new words as well. But anyway, point being, we probably wouldn't implement this with an asymmetric dispatch kind of a scheme. What we'd probably do is when this collision occurred, we'd just look at what the velocity of the player was and ask ourselves whether they were or acceleration or something, whether they were trying to accelerate into the block or not, right? Or whether they had a velocity that was moving them into the block at the time or not, right? That's probably how we would make those kind of determinations, not who happened to be which variable in a collision detection call, because that just doesn't seem like the sanest way to do it, since that's really just an artifact of how we choose to process our collisions. We may want to process them simultaneously. We may want to do all sorts of things with how we actually compute collision. So it's probably not a good idea to bake how our logic works into that system, right? So typically, if you think about what we're doing here, we're typically only specifying sort of this upper triangular part of things. And we're just going to assume that when we do things, if we were going to process a collision that looked like this, we'd just instead handle it like we would if it was the other way round, right? Which is a pretty trivial thing for us to do. So even with that constraint, even only filling in half of this matrix, we would ask the question, right? And you should ask the question, how many dispatch routines do you have, right? How many dispatch routines must you write? You write, right? And you should be able to figure out, like this is some pretty basic math, right? How many entity types are there? If you wanted to fill in the whole matrix, right? How many dispatch routines would you need? Well, you would need the number of entity types, right, squared, right? Because what's the area of a square? It's the side times the side, right? So t times t would tell us how many t squared is how many dispatch routines we would need, right? And in this case, we only need to supply half of them because we don't actually need these ones down here. So we actually get to remove a fair bit of them, right? So we only need half of them, but not exactly half of them, because half would cut it right down the diagonal, right? But we're not really cutting these squares in half. We actually have to fill out the entire square of the diagonal, right? So we actually need a little more than half of them, right? But I don't super care too much about that. We could even say, let's just say it was even t squared over 2. We don't really care too much. The point is the t squared, right? That's the part that should scare anyone looking at this. Because if we were to graph that function, and we've talked about this before, this kind of gets back to the concept of order notation, right? I don't know if Google can graph these things. I think someone was saying that it could. Yeah. So basically, if you look at what happens when you graph something like this, right? And let's zoom out just a little bit here so you can kind of see. So what you can see when you have a squared function is that it doesn't take very many entities to start getting up into absolutely intractable numbers. If we only had 20 entity types, we would already be at 400 dispatch routines. And even dividing that by 2 knocks it down to 200. Who cares? That's way too many dispatches for only 20 types of entities, right? And so typically what I like to point out, and this is sort of something that gets at the heart of how we're going to be handling game logic as we go, or at least my approach to it, how I tend to look at it, is these sorts of things are relatively untenable, right? And so the double dispatch problem is a very real problem. It's very problematic. It's a t squared sort of a thing. It's an O, typically also people will write that like this, ON squared, right? We haven't really talked about order notation much, but basically when people use this kind of terminology, what they're talking about is how does the problem that you're dealing with scale up as you increase the number of elements. So you can think of n as basically how many things are involved, and O something with an n in it is telling you what the curve looks like, right? What that curve looks like as it scales, as n increases. So basically our order notation for that curve looks awful. It looks like this, and somewhere around here it becomes intractable. So it's not the kind of thing that we want. And so one thing that you might ask is like, whoa, how do games deal with this problem? And the answer is they deal with it in two different ways, and we're going to be taking sort of, we're definitely going to be sort of focusing on the way that I think is a better way. Basically, some attack it head on, and they say, we're just going to go ahead and do double dispatch, and we'll write code for all these things. And what that basically means is you just don't have very many entity types, right? Either the entity types are few, or the responses are few, right? Because you can imagine one way we can do this really simply is saying, oh, well, when monsters hit monsters, nothing happens, right? So lots of our stuff just doesn't have anything in it. A lot of these are just null. And we don't have to do work to handle null things. So what we do instead is we say most things don't interact with each other, so it's not a problem. Or we say there just aren't that many things. So even if they all do interact with each other, well, the number is 5, so we wrote 25 dispatch calls, right? Or divided by 2 and right, whatever, right? So there's not very many dispatch calls. So that's one way to deal with it, right? And, you know, you can think about this sort of thing, especially this one right here. This is kind of the AAA methodology, right? The idea is we actually hand author most of the stuff that happens, right? It's like there's a lot of cutscenes and a lot of custom things and like, oh, you went and the helicopter exploded on the roof and blah, 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 right? And so the responses, there's not very many responses and they're just hand authored. And we just hire a lot of artists to get that response number up to enough things and enough game scripters to just do that, and it's fine, right? But on the whole, there's just not that much flexibility. If you're playing Call of Duty, there's just not that many interesting emergent things that can happen in that world because there just aren't that many, you can't script all of those different things. You can't create for a single Call of Duty level that you might play through where Kevin Spacey's coming and talking to you. Well, everything that Kevin Spacey was going to say had to be recorded by Kevin Spacey, right? And so there just isn't that much that can go on there. And so if you're in that sort of if your game has a lot of AAA-ness to it, right? If your game is kind of in a AAA-ness kind of a situation, right? Then the double dispatch problem really isn't that much of a problem because you know that you're just going to have that sort of a hand-authored, sort of scripted-y kind of a thing happening, and it's fine, right? Think also adventure game, right? Like there may be 20 objects in this adventure game right now and 30 things on which you could use those objects, but you know what? Only one of them works to solve the puzzle, so we didn't even bother writing anything for the rest of them. It just says, I don't think that will work here, right? And so double dispatch problem solved, right? Because there's only one thing that actually will make the game go forwards and everything else just wasn't handled, right? So we'll call this AAA-ness or we'll call this adventure style, right? Okay. So I don't think those are very interesting because, at least lately these days, the kinds of games that I am often the most interested in are ones that have a lot more richness into the way that they allow things to interact. And so what I'd rather do is focus on ways in which you can get this matrix filled without actually writing all of the different things, right? So rather than focusing on a double dispatch problem where we essentially have types that interact with each other, what I'm thinking is more along the lines of, you know, fundamental qualities, right? So rather than thinking of an entity as a monstar or a sword or whatever, what I'd rather do is just think of them as having fundamental qualities, and we write interactions for fundamental qualities so that the fundamental qualities, what we're essentially doing is projecting down a level, right? Basically like our entity types, because we know that if we wanted lots of sort of variety in here, we just have it just be an untractable problem. Could we just boil it down to some set of fundamental qualities, and then our entities are just compositions of those fundamental qualities, right? So let's say we could do, you know, 8 fundamental qualities, right? Which is fundamentally somewhere along the lines of, you know, like 40 different interactions between those fundamental qualities and those sorts of things, or who knows how we want to write that exactly. You know, that's a manageable number, but then our entities are described in terms of these things, right? And those fundamental qualities can be sort of component-based in ways that allows us to avoid the double dispatch problem. So instead of thinking of a monstar, right, and a hero, as two different things, they're just the same thing in our system, and they just have different fundamental qualities or properties, right? Like this is, oftentimes it's called a property system, right? And so things will be more defined by the properties that they have, right? Rather than by a single type. And what that lets us do is it lets us fight an n-squared problem with an n-squared solution, right? If we want to have a lot of entity types, but we know we can't possibly write the code that is how all of them interact, but we do want to have all of them interact, what we can do is say, okay, instead of making that many entities, what we'll do is make smaller pieces, just little fractions of an entity that you compose together, right, to build up what the entity actually is, and there may be a very small number of those. But because there are 8 of them, right, and an entity is built out of some number of them, let's say 5 on average or something, that gives us, right, an 8, right, to the 5th power version of a composition, right? Because if the first property for an entity can be any one of 8 things, and the second property can be any one of 8 things, and the third property can be any one of 8 things, right? And I guess it's technically probably 8, 7, 6, so it's probably more of an 8 factorial kind of a situation, right? 8 factorial is a massive number, which allows us to put a small n in here and get a large number of potential entity types out. And so what we're doing here is we're fighting an n-squared game design problem with an n-squared game design solution, and that tends to be the more fruitful place to go, I think, right? And that allows us to talk about things like, let's say we have magical essence, right, as one of our things or whatever. We just write the rules for magical essence and how it interacts, and now anything just has a certain amount of magical essence to it, and that allows us to make very, very many different, every kind of monster that we possibly have in the game. We can now have many different types of them. There's the kinds that are, for monster A can show up as monster A not magical, monster A a little bit magical, monster A medium magical, monster A very magical, right? Just by setting the number of their magical essence, right? And so that's really kind of the interesting part that I think that I want to go for, is what are the interesting components that we can create such that putting different combinations together yields interesting types of monsters and objects, and then we're out of the business of this. So we still do have the double dispatch problem, but we have it on a much smaller scale, and that allows us to basically get up to more sets of possible interactions that the player will witness without actually having to drive ourselves nuts, right? And so that's kind of what I'm aiming towards. So for now, we will sort of say, because we haven't gotten into that element of entity design yet, when we process these, we'll do it in the sort of old school double dispatch way, where we'll just kind of handle a few of the things. We'll do the triple anus version, right? Where we handle only a few of the things. But the eye towards how that we're going to solve this for real in the future is when we have sort of when we actually go and do how we want our entities to be composed and built. What we'll do is at that point say, okay, now what we're actually doing when we process collision is processing the collision of those properties, not the entity types. And so that's where I would like to get to eventually. But baby steps, one thing at a time. So when we come in here, what we want to do is we want to sort of handle that. So I'm just going to pull it out of here for now, so we can kind of see it a little more clearly, and know that we're going to replace it with something different in the future, right? I'm kind of putting this in as a thing. It's like, hey, we know we're going to replace it, so I'm going to pull it in a separate function because I know I want to write another version of that function eventually and be able to do that changeover. So yeah, so this is not, I'm not making, what I'm trying to say is I'm not making a function because anyone else is ever going to call this function. This is purely me saying I want to be able to write a second version of this function and swap it out eventually. So I kind of want that flexibility there. All right, so when we have this, what I'm going to do is I'm going to say, all right, I'm going to say handle collision, and I'm going to pass that handle collision to entities. I'm going to sort the entities by their type. So basically, I'm going to say we've got a sim entity A and a sim entity B, and I'm going to start out by assuming that the entity that we got called with is entity A, and I'm going to assume that the entity that we hit is entity B. But then what I'm going to do is I'm going to say if entity A, if its type is greater than entity B's type, right, then I'm going to swap the two, right? And I don't know that we ever wrote any swap code. I don't think that we did. I could be wrong about that, but I'm pretty sure that I didn't specifically because, yeah, we did not ever write one. So that's fine, doesn't matter. We'll just do temp equals A equals B equals temp, something like this, right? So we'll swap those two guys. And basically what I want to do is I just want to make sure, right, that whichever one has the lower entity type value comes first. That way, that is how I am solving temporarily, right? This triangle, where did I go with that? Where is it? Where is it? There it is. That is how I'm preventing us from ever being down here in the lower part of the triangle, right? I basically am just saying, let's always talk about the lower value first. So if we got past S as the first parameter and H as the second parameter, right? I'm sorry. If we got past, depending how you think of this, I don't even know which one of these I'm thinking is my row and which one is my column. But point being, if we got past this square, by swapping them and knowing that I always have the lower one in the first entity and the higher one in the second one, I'll be able to do write my operations as if this always got past, you know, as its flip around, right? As this guy, right? So we're just doing that flip, so that everything always gets mirrored up into that upper diagonal, if you will. So when we handle collision between A and B, like so. And so, like I said, there's a number of things that we could do here. We'll do a really simple one for now. I'm just going to go ahead and say, all right, internal void. Here's my handle collision. I've got some entity A, I've got some entity B, and what I want to do is I'm just going to start saying some stuff, just totally randomly typing in here. Let's say if type A equals something and type B equals something, then we're going to do a response, right? The simplest possible thing you could think to do here. So let's see, if the, which is the one we wanted, if the entity type sword, right, where is my entity type, let's see here, handmade, oh, and you know what I could do? I can make this even better. Let's do inline bool 32, if types match, right? And that will basically say we'll pass the A and the B, and we'll pass the types that we want them to be. So let's go ahead and look at our sim region type here. So these were entity type A type, entity type B type, right? And so what I want to do here is say, okay, we'll see whether what I don't want to do is I don't want this code to have to know which one of these is the lower one, right? So what I wanted to do was say, okay, it's going to pass these two in, and this guy will swap them around again potentially for him. I'm trying to think of exactly how that would work. In fact, I guess this handle collision call doesn't even have to do it. Yeah, so the problem I'm trying to avoid is making you have to pre-sort all these. We could just do that, and maybe I'll just do that for now, and we'll talk about it tomorrow. But basically what I'm worried about here is if we change the order of these identifiers, then these matches won't work properly, right? The sword always has to be on B because it comes later than, for example, the Monstar, right? So what I would want to do is potentially write this in a way that makes sure that you can always test them and not have to care. But I won't deal with that for now because we only have 5 minutes left or so because we started about 5 minutes late. We only have about 5 minutes. So I won't get into that now. That's what I was thinking. That's what was going on in my head right there. So if we have a Monstar sword collision, then maybe what we want to do is make the Monstar's hit points go down, right? Or something like that. I don't really remember, because it's been a long time since we did that, what the hit point situation was. But I guess what we'd do is we'd scan through for the last hit point, and we would remove some of it, right? So we'd take that filled amount, and we would sort of make that go down. So, but for now, the other thing that I could do is just subtract from the hit point max, since again, we're mostly out of time, so we could do that. But eventually what we want to do is actually process the hit points, you know, do something kind of useful there. So what we want to do is just say, okay, if the sword and the Monstar hit, then we'll go ahead and do that. And maybe we also just, for now, we'll just get rid of the sword as well, right? So we'll make entity non-spatial. We'll just say the sword just goes away, right? It goes back to the hilt or wherever swords go. And so that should do it for hitting the monster with the sword. Now, unfortunately, I believe this will do nothing when we actually run it. At least that's my assumption, even though it clearly hits the Monstar. And the reason for that is we have said that the sword does not collide with things, right? And that's what we wanted. We don't want it to stop when it hits things. But what we want to do is still process collisions. So this was the other thing that we wanted to do, was introduce some kind of flag that controls whether when you run into things, you stop, versus whether you collide at all. So instead of making collides only mean essentially that you detect collisions, or sorry, that you detect and respond to them, what I want to do is make it so that there's a way to say that you respond to collisions, but you don't actually have your movement impeded by them, right? And so trying to think about how that would work, basically if the person who is being moved at this time, right, what I want to do is say, let's just say we don't check that flag, right? We don't check the collides flag here, okay? Everybody always does collides in that way, let's say. And we'll do that processing. The only difference is when we come through here, we won't actually set that tmin lower in the case where the collide flag is not set, right? So basically what we're going to say is that the movement always actually totally works in the case where the collide flag isn't set. So we basically have a thing which is when the entity stops on collision or something like this, is going to be that flag, right, if that's set. So we'll compute this at the outset. We'll just say if it stops on collision, that's what's set. Oops, we got a syntax error in here. What's my syntax error? There's closing parentheses, right? So we'll say if it stops on collision, we'll find that out. And then what we'll do is we'll say when we do our little tmin processing here, that will be used to figure out who actually is the first one hit. But when we actually go through and do our collision processing, we will not actually, so we'll move it to the right location, we'll do the hit collision, but then we'll continue it, allowing it to basically go forwards, right? So what we'll do here is we'll say, let's see, player DP. So we don't want to actually process any of these things at all, right? We don't want to change any of this player delta stuff. Desired position minus entity. Well, I guess we do want to update it. We just don't want to change its direction. Seems about right to me. So we want to do, we don't want to change its velocity like so, right? Because this is the velocity change. And we don't want to clip its movement. So it looks like player delta is not being used in here. So I think I can just do this. If stops on collision, we do that. Otherwise, we keep going like so. And then we also will have to do a little bit to do in this particular case when things are supposed to keep going through. Need our collision table here, right? Our thing that says whether you've already collided with someone, because we talked about doing that, but we haven't done it yet. So let's just see if that works at all. So now, oh, well, we do have one problem. Our collision thing worked okay, but we have a problem with this guy actually collides with, when it actually collides, it gets stopped because it keeps hitting the thing that's colliding. And we're going to need the thing that says don't keep colliding with someone you already collided with. So we need our collision table thing. That'll be the thing that we'll deal with tomorrow so that you can sail on through those things. But all right, I think we're basically right on time, 9:05. Now would be a good time to start the Q&A. If you could please prefix your questions with Q: so I can see them. And if you could keep it to stuff that we've coded on today's stream or on previous streams. If you want to ask off-topic questions or stuff about code we're going to write in the future, please come before the stream. Do that in the pre-stream. Come about 15 minutes before one of our scheduled start times and ask the questions there. Tomorrow morning, it's an early one, tomorrow and Friday. So come tomorrow morning and ask those questions, and we will talk about them. But let me see if I can launch the Q&A here. Yes. I'm so glad that the Handmade Hero bot listens to me now. I don't know how I gained this privilege, but thank you for whoever made the Handmade Hero bot respond to me. It's pretty cool. All right. Okay, so let's see. Questions. Does anybody have any questions? Or did everyone just understand everything and we are good to go? Which could be true. How long, in your opinion, does it take to become fluent on Emacs? I have no idea. I started programming in Emacs in 1991. So I don't remember when after that I was pretty comfortable with it. I don't think it took me that long, but I don't know. Could an entity have multiple fundamental quality property things? Yes, my idea is that basically that entities will be composed of as many fundamental properties as we choose to implement. So like, I don't know how many fundamental properties we'll end up with, but entities will be able to have as many of them kind of on them as you want them to have. Handmade Hero Bot will listen to you if it feels like it. Seems to be agreeable today. Oh, so is it a temperamental bot? The bot on this? It seemed to be working for me. It worked twice in a row. I feel like I did it yesterday too. Maybe, I don't know. Can't quite remember. New ISP for the love of Pete. Are you sure it's me though? A lot of times it's not me. But I don't know. Like a lot of times. So for example, oops, I don't want that. A lot of times my internet's just fine. Like if I go, like I actually have full bandwidth, it's just I can't get to Twitch, so I don't actually know that it's that it's actually the ISP. I don't actually know how to let me put it this way. If anyone knows how to even determine if it's my ISP, that would be a very handy thing to know, because I don't know how to figure that out. Because like I don't seem to be having trouble communicating with other sites, and when I go to try and test it, right, I don't find that I'm getting a lot of indication that it's my ISP. Like my ISP seems to get out just fine and relay traffic just fine from simple testing. So I feel like a lot of this is just Twitch, and there's not a lot I can do about it, but I don't know. So if somebody knows how to determine that definitively, I'd love some help with that, because I don't know how to figure that out. When are you planning to add depth sorting? I don't know. I've been feeling kind of like we might want to start the renderer sometime relatively soon, but I think we might do animation first. So probably we'll do animation, and then we'll start the renderer and just do the depth sorting when we do the renderer. Will there be enough entities that some optimization will have to happen? How many do you expect to have on a screen? Hundreds? I don't know if there'll be hundreds, only because screens just ain't that big. Looking at it, our hero is a little too big right now, so he'll be scaled down, but the trees, the trees would be roughly that size. I don't know how many, 100 entities would probably be typical, but hundreds of entities, maybe not. Now our sim region will have hundreds, because if there's 100 on a screen and we're like doing 9 screens or so, then there'd be 900 entities or something like that. So there'll be a lot, but whether we'll have to optimize very aggressively, I don't know. You have to remember a lot of the entities are things like trees that are just sitting there most of the time, and so if they're not actually being actively used for something or on fire, or who knows what will allow to have happen to trees, but they don't cost very much to simulate if they're just sitting there. So I don't know how much optimization we'll have to do. It really depends on what we see at the time after we've actually got real things in there and the gameplay is roughly what we want, and we're like, yes, this is good. What's our performance like? And who knows? And it might just be fine. It might be bad. I don't know. Obviously, we will want to optimize to run large worlds, because that's something that we did a lot of time up front to make sure we'll be good to go on. So I suspect maybe that is where the optimization will actually come in, is when we want to start scaling up to like super huge worlds just for fun. That might be more of the place for that. I'm not sure I quite follow your argument for double dispatch table versus fundamental qualities. Seems to me like you still need to figure out what to do for each quality, what to do in the presence of others still leads to quadratic growth. I must have missed something. No, so that is correct, right? The idea is that you can't avoid quadratic growth if you want to have rich interactions. So the question is, what is a type to the player, right? So what does the player think of as a type? If our type in the code, right, equals the player's type in their brain, that is where we have an sort of what I would consider an intractable dispatch problem, an intractable dispatch. Because if we want the player to think that there are 100 different monster types, then and 50 different swords, right? 50 swords and 100 monsters, right? Then now we have 5,000 different ways that swords can hit monsters, and we're in bad shape, right? That is no good. So what we want to do, and what games I think that do these sorts of things effectively do, is they think of things in terms of their properties rather than by what they actually were, right? So instead of thinking of things as this is a particular type in the system, you want to think of it as, okay, it's actually a composite of several different types of pieces of information, such as the fact that it does damage, physical damage, magic damage. You know, think Dungeons and Dragons, right? You've got properties, like fundamental properties, that you've broken down, and yes, you have to do a dispatch problem, but it's on like 10 stats, so you have 100 things you have to write, rather than it's on the individual types that are there, right? And so that's what I'm basically saying is you want to make sure that this is not true. You don't want your system types to equal your player-facing types. And so it's a very simple concept. It's not new. It's like I said, games do this all the time, but we've never talked about it. So this is the tack that I will be taking, is where our types are fundamental things that maybe aren't even necessarily exposed to the player. They're our internal model of how things interact. And then what the player sees is sort of player-facing types, which are more fictional and more meaningful to them, but that are actually not about the simulation directly, right? Does that make sense? And so that basically allows you to have a lower number because you get, if your types compose to build the player types, right? Then you can have, 100,000 player types. How would we do that? You'd be like, well, I just have to have enough of my types so that we could build that many player types by composing them. And so 8, like I said, I picked that number. Like, let's say we have 8 of our types of things in the system that can compose to be players. Well, if I wanted to build a player type out of this, something that the player sees, well, if I have 8 of things to choose from and I want to compose one, let's say I pick from the 8 for the first property this thing has, and then I set it to have some value. I got times 7, times 6, times 5, let's say, so we've got 4 properties there. That alone, without even considering what the values of those things are, just the fact of which ones I picked, right? In which order I picked those, gives me some pretty powerful numbers to chew on. But it's kind of a weird way. It's not really directly that way. That's not the way the combinatorics actually work out, because it's really the fact that you can set these things at different values that also makes it important, because you might not care what order things go in, right? These might not be order dependent when you build things up. So that may not be entirely true. But the point is, if these things have different values that actually mean stuff, then as we compose them together, setting the different values to different things is what will determine how these monsters behave, right? And so the example there is like, let's say we've got, in the case of, or let's just take just straight movement. So we've got how something moves, right? We've got a speed property, let's say. We've got like sort of a flying kind of concept maybe, right? We've got like what they can walk on. So, do they have, can they walk on water? Like, so we got restrictions, right? So like, can they walk on water, fire, that sort of stuff? When you take these things together, you can start to produce a lot of classes of things that can move, because you've got how fast it moves. So that gives us a whole range of things, right? There might be like 4 or 5 or 6 different classes of speed, right? So you've got, 5 things there you could set. You've got flying or not, that's a Boolean, and maybe there's heights of flying. There's like low flying things and high flying things and non-flying things. So that's 3 different settings there, right? And you got restrictions. Can it walk on water? Can it walk on ice? Can it walk on this? Can it walk on that, right? So there's probably, maybe another 4 different properties you get out of there. So just for the movement of something, if we're thinking of it in these terms, we now get 5 different types of things times 3 different types of things times 4 different types of things. And that right there, right, is going to lead us to 60 different types of monster movement. And so I feel like that's always the way you want to think of it. If you're trying to write a game that has lots of different things and lots of different interactions between those 3 things, you want to always decompose it like that and do your dispatching on the decomposed things, because that's a lot more manageable and allows you to leverage the multiplication to get you up to higher numbers of player-facing types. Whereas if you actually have to implement each player-facing type, you don't get multiplication. You don't get that power of multiplication. So you're fighting this problem without the aid of the same kind of multiplication on your side. That's the only real thing that I was trying to say. Yesterday you were talking about using callbacks to the collision system. Will this new system replace the need for them? I thought where I landed on that when I thought I was just saying callbacks are an example of how you would do that in there. And I thought what I was saying is we don't need to do that because we'll just handle them inside this routine as a symmetric sort of way that things are handled. I thought that's actually what we said when talking about it. If not, then that was my bad. I didn't mean to imply that we'd use callbacks. I thought I was just saying callbacks are something that people often do use in this situation, but I don't want to because they have flow control problems, right? Casey, I asked a question in the Twitch app, crashed on iPad. Any chance you saw my questions before it did? I don't think so, because I don't see any of them on here. So you may have asked them before I started the Q&A. Trace route to Twitch. Trace route to Twitch. Oh, whoops, it's trace RT on Windows. You can see my router. We'll see what this goes to. I'll answer questions while it's doing it. This is EE Twitch's question. Casey, as a casual observer and occasional troll, where's the game now? Seriously haven't watched for a while, and how do you find the energy to do this weeknights? I don't know. It's not that hard to program for an hour on a weeknight, I mean, I like programming, and I would just be doing something on my computer anyway, so I feel like that's usually, that's usually how it goes. In terms of where the game is now, like I said, we're on our 68th hour of programming. I think it's really more like our 70th hour, because we had a couple, like 1 or 2 streams where I went an extra hour. Just like ones that were on Fridays. I did a little extra extended session ones. So we've programmed for 70 hours. So we're in another 10 days, on day 78, we'll have completed 2 work weeks worth of code. So if you sat down on a Monday, you would have programmed for a week, and now we're on our 2nd week, and we're not quite there yet. In another 10 days, we'll be at the end of that 2nd week. And in those 2 weeks of time, I think I'm pretty darn happy with where we've come. We wrote our own Win32 code, startup code and all that stuff. We wrote our own automatic DLL loading, loop live code editing, all that stuff we wrote. It was good. We've got our sort of primitive sound and video output, which we needed just to get started. We wrote our bitmap loading code, our bitmap blitting code. We've now written a system to handle giant worlds, so we can have absolutely huge worlds now if we want to, that we can walk around on. We can smooth scroll or do room-based scrolling, because we sort of decided we'll do both of those. We've got a simulation region thing now that's designed so that we can handle sort of whole world sort of stuff happening at once, so other entities can be doing stuff in the world other than where you are, and we kind of set things up to try and handle that. And we're right now sort of doing our sort of collision detection entity property stuff, just a little bit of that before we go into animation. So I would say we're probably going to close in at the end of that 10 days. I would say at the end of 2 work weeks, I would say we're almost done with engine architecture as well. We've got a little bit, I think animation is going to take us a little while. But once animation's done, so I would say probably somewhere around day, let's say 90. 90 to 100, which is not even 3 full weeks of programming. So hardly any time at all programming-wise, right? We will be at the point where we're totally ready to do the game proper. We'll have a complete like sort of game framework running with all of the pieces in place, and we'll just have to go through and then start doing some of the heavy lifting. We'll have to write the renderer for real, which is going to take a while. Then we'll have to write sort of the some sound stuff, which probably won't be too bad. Sounds a little easier. And then we'll have to write, and those will be like the shipping versions of those things, shipping render, shipping sound code. And we'll do, after that, then we'll start on the shipping, game, basically. And honestly, yeah, I couldn't be happier with how it goes. I'm nervous about the renderer. I know rendering, it's kind of a big topic. And so I'm a little nervous about that. I don't know how long that's going to take. That could be something that really derails us. But, what are you going to do? I don't really know. Yeah, I don't really know what to do beyond that. We've got to write it. So I would say I'm delighted with our progress so far. I think if you actually map it back to how long it would be if we actually sat down and code, we're in great shape. Yeah, and if we can keep going at this rate, I think we will actually, the project will go great. But obviously there's plenty of opportunities for us to stumble, and I don't know how we'll do because programming is always difficult and unusual, and there's only so much you can do about that. But that's basically where we're at, and I'm really happy with how it's been going. I noticed sometimes you try to determine regions for collision boxes. Why not implement basic shapes and use those as debug helpers with some alpha percentage? Just because I don't really care about that stuff right now. By the way, this is kind of bizarre. I'm assuming that this is where people stopped our trace route. So Twitch is probably somewhere in here. It looks like this changeover is pretty nasty. We went from 3 millisecond pings to 60 millisecond pings. But I don't know. So somewhere right about here, stuff gets bad. But even so, I don't know who's dropping packets, if anyone is. But people who want to see the trace route, there it is. So that's what we got. Anyway. So, yeah, I would basically say that the collision box stuff, we don't really need debug helpers because we're not really writing any code that's all that interesting in terms of like nailing bugs and that sort of stuff. We just want our engine architecture set up. So what we're going to do is when we go down to do the rendering side of things, which will happen in a little bit from now, we will be building out our debug services with the renderer, because the renderer will give us the first opportunity to start doing a lot of debug drawing, like debug lines, debug that sort of stuff. And because we haven't needed debug services for anything right now, I don't think it's worth spending time writing some debug stuff of that in advance of doing it kind of all as one system. That's my opinion. Do you test for collision every update interval if your sword overlaps with an entity? Could it happen that a moving entity gets missed because both entity and sword move in the same tick above and beyond each other? So not right now, because right now we actually don't do simultaneous move. What we do right now is in order move, right? So basically, if this is a frame, right? Well, actually, no, that's not true. So yeah, I guess what I would say is yes, what you're saying can happen, because right now we don't actually do simultaneous move. So let's say you had a situation like this, right? Where the sword was going this way and the thing that was going to hit the sword was going this way. And it just so happened that their velocity was such that they probably should have hit right here. We would not detect that because first it'll move this guy here and see that there's nothing in its way, and then it'll move this guy here and see there's nothing in its way. Now, in order for that to happen though, the sizes of these guys proportional to their movement have to be very small, which currently we don't have. So in practice, I don't think you could ever actually construct this case. But in theory, if you cranked the size of entities down very, very tiny, so they were just like points on the screen, or you crank the speed of entities up very high so that they were moving very fast, then you could get this situation. And that situation is what would compel, if you care about this, which when we do our collision detector, we might decide to care about this specifically because it's interesting to think about how to solve it, right? And it leads to a more complicated thing to solve it. You need to basically do stuff where you kind of consider the motion of entities together and say, would these guys have collided if they moved continuously, right? So yeah, so I guess that's what I would say about that. I don't think it can actually happen right now because of the size of the entities, but the algorithm doesn't actually handle it, and so technically you would be able to create things that could do it. And so it might be interesting when we do the full collision detector to actually check for that, just to show how to do it. To me, it seems as the sword acceleration should be influenced by the speed of a player movement at the time it was dispatched. Am I right? Yeah, so if we're not actually at the point where we're doing that kind of code, but when velocity is always relative. So if I throw something and I am running, then when I throw it, it should have my velocity plus however much of velocity I pointed to the throw, right? That's just kind of, basic physical kind of stuff. And so if you wanted to do that, what you do is when you set that sword velocity, so like, in here when we sort of when we launch that sword, right? When we launch the sword forward, I believe what happens, if I remember correctly, is it just, where does it actually set it? Here it is. I'm like, we throw the sword here somewhere. So when we actually throw the sword here, that's not it at all. You can tell I'm kind of out to lunch today. This is where we actually show the sword. So when you actually throw the sword, when we set that velocity for the sword, right? We set it right here. What you would do is you just add in however fast the hero was moving. Because whatever that velocity, it's not the acceleration doesn't change. Acceleration is independent of that. So what you're actually doing is you take the amount of velocity you want the sword to have, and you'd add however much velocity the hero had at that time, right? So that's this. It's like that, right? And so that way, when you're running things now, and of course we still have our problem with the with it colliding. I can turn that off for a second so you can see, because until we implement that table, it's going to keep getting stuck on the hero basically, because it's like I can't get out of the hero. There's actually another way we could choose to handle that, but I want to implement the table as well. But we've got so many things we could be doing. But anyway, so in the sim region, if I was to turn this off, right? So if I was to say that collides thing like we were doing before, where I basically say, and it stops on collision like we were doing before. Now, when I do those things, right? You can kind of see that if I'm going in this that's funny. If I'm going in this direction, it gets a lot more. If I fire it in the same direction I'm going, it gets a lot more heat on it, right? But if I fire it in the opposite direction I'm going, so let's say I'm moving this direction and I fire it backwards, it goes a lot slower, right? And that's technically how that would work. So if that's what you were concerned about, that's the way you would want to do it, right? So yeah. But again, we're not really at the point where we're thinking about code. That's like when we start to do the animation stuff, we'll start talking more about like that kind of tuning stuff and those sorts of things. I missed the part on how many entities you are simulating at once and where you store them, but won't the dispatch table approach be negative for cache performance? Could its simulation be deferred? Yeah, like it's a little premature to think about stuff like that because we first have to see whether that's actually a big deal. Because what you have to remember is that dispatching only happens when two things hit each other, which actually doesn't happen that often. Right? You're only talking about a few of those per frame at most, probably, right? So chances are that dispatch is not going to dominate the runtime of the collision routines. Figuring out who collided with who is probably going to be the cost, and the dispatch to handle it is probably not going to be that big a deal. But that said, I don't know that. Depending on how we actually implement things, it could be the other way around. So it's a little bit too early to think about that because we really just don't know. And we'll have a better idea later on as we go what needs to be optimized and what doesn't. But at this point, it's definitely not worth worrying about because we don't even really know what kind of load is going to be placed on that dispatch in the first place, you know, and whether we even have to optimize it at all. Don't do traceroute again because everyone got to see you freeze. Okay, I don't know what that means, but okay. It seems logical to make infinity the default maximum distance an entity can travel, but that could have performance implications. Can you say something about that? Well, so the reason that I didn't set it to some random floating point number, like infinity or like float max, was just because you can get into troubled situations where, like, if I go in here and I was going to end up doing something with the distance remaining, I don't want something that's going to create any sort of exceptional floating point situation. Because since the floating point units handle things, special numbers like infinity or stuff like that, or overflowing a float, since they handle those things specially, I don't want to put it in a situation that would make it uncomfortable. So I just need a number that's large enough that I know that I'm never going to hit it, so it's practically infinity. And so I find that it's usually better to do that than to actually use infinity, because you don't know on what platforms you're on, what's going to happen if you actually try to do an operation with infinity. And I don't want to bring in that because I never remember all those things, and I don't want people to have to remember those things to write this code because it's not necessary. So that's why I just picked a high number instead of using an actual floating point infinity or something like that. All right. Last couple questions here. Could you also do something like that for AI, where, for instance, you can impose simple behaviors on top of each other randomly to make complex and varied behavior instead of doing the more common behavior tree approach? Yes, that's actually what I was planning on doing. So we'll see how that goes when I go to do it. If you do the triple anus way, can you come back to it later and edit or add more details to it, like from 6 to 8, etc., or will that cause problems? Sorry, I'm not sure I understand the question exactly. All right, I think that's it. All right. Okay, I think that went relatively well, except for the problems with me sending packets to Twitch, unfortunately, which seems to not go as well as I guess I would like it to. Okay, so let's take a look here. Go back in. I want to see how badly we ended up doing. Yeah, we had a horrible, this was absolutely horrible tonight. And again, I have no idea why. I don't really have any way of figuring out what that actually is. If anyone has any ideas, if I can figure out if it's an ISP problem or if it's just Twitch and there's nothing I can do, it would be pretty great to know, because I'd like to get it fixed. It doesn't happen that often, but every N nights we get this problem where we just can't seem to do anything. So it'd be nice to get that resolved. Anyway, thank you everyone for joining me for another episode of Handmade Hero. It's been a pleasure coding with you as always. If you would like to follow along at home, you can always pre-order the game on handmadehero.org. And it comes with all the source code, so you can follow along at home. You'll get a little link in your email that you can use to download the source code every night. And I upload it after we finish coding every time. If you want to support the video series, we also have a Patreon you can subscribe to. It's linked off of handmadehero.org. We also have a tweet bot that tweets the schedule, so if you want to know when streams are, you can always find it there. And finally, we also have a news and forum site, which I highly recommend checking out. It's got discussion boards on it you can go to. I answer questions there, and so do other programmers. It's also got ports of Handmade Hero to other languages and other platforms like Mac and Linux and so on. So if you want to see community, people have done ports like that sort of stuff. If you want to run on Mac or Linux, that's a great place to go to get started on that. And also, we also have annotated archive, an episode archive on there that you can go to, which helps catch up with old episodes if you're new to the series. So I highly recommend checking it out. That's about it. I will be back here tomorrow morning. I believe it's 9 a.m. Pacific Standard Time tomorrow. Hope to see you guys there for some breakfast coding. If not, I completely understand. Have a happy Thursday anyway, and I will see you guys later. Take it easy.